Okay, Assalamualaikum and good morning everyone. So if you can hear me, so please let me know in the chat box. If you can hear me, please let me know. Dia tak dengar suara saya. Kita nak start dah lecture kita pagi ni. Okay. Assalamualaikum Elida, Liana, Sanakian, Mira, Azra, Syazwani, Syamish, Syazwani, Madumita, Syamira, Najwa. Dia dengar tak suara saya? Okay, boleh. Thank you Sanakian. Can hear. Okay, thank you Azra. Boleh dengar Alright. So screen pun boleh nampak. So let's get started. Okay, so kita dah nak habis dah topik 2 ni. Dan minggu depan pun kita dah kita akan masuk kita akan start topik 4. So minggu depan kita ada UPS 1, topik 1, 2 dan 3. So this is the last subtopic for topic 2. So as you can see, topic 2 ni dia adalah continuation kepada integration punya chapter. So you have to know how to integrate in the first place, and then for this topic 2, you have to know how to integrate if it's given a differential equation to you. So apa itu jenis differential equation? So untuk tahap awak di matrix ni, awak hanya belajar first order differential equation. Maksudnya kita tak jumpa yang d squared y over dx squared. Kita tak jumpa dy dx kuasa 2 tu, kita tak jumpa. So yang awak jumpa hanyalah first order differential equation yang kuasa dia 1 sahaja. Okay, so there are two ways untuk solvekan kita punya differential equation. It's either first we have to consider to separate the variable, and the second one is if we cannot separate the variable, we have to do integrating factor. So that's the techniques that we have to do in order to solve the differential equation. So 2.1 again is separable variable. 2.2 adalah integrating factor. You have to do exercise on those two techniques untuk awak lebih faham apa yang kita belajar dalam separable variable dengan integrating factor. Okay. Last one adalah application. So application ni dia melibatkan differential equation juga, tapi dia tak bagi straight away solve the differential equation, tak. Tapi dia bagi dalam bentuk real life problem. So many problem, as you can see in my screen here, many problems in physics, chemistry, biology, social sciences and economics can be mathematically stated in the form of differential equation. So that's why kita belajar matematik sebenarnya, because maths ni involved in most of the science area mesti kena belajar matematik. Tak ada pun, saya kata tak ada pun orang yang tak ambil matematik kan. Mesti semua orang ambil matematik. Alright, so kita tengok. This includes Newton's law of cooling, electrical circuit, population growth and radioactive decay. So kalau awak Google lah all these things, all this law, Newton's law ni, electric circuits punya law, population growth dengan radioactive decay especially, you will find there is something that you familiar with, which is the differential equation yang melibatkan d over apa tu, d lambda over dt. D kalau Newton's law of cooling, d theta over dt. Okay, kalau electric circuit, di. Okay, current, di over dt and so on. Alright, so those are some of the application that you can see. So let's see some examples. So, kita tengok Okay, so bila dia bagi soalan untuk application, dia dah tak pakailah y dengan x saja, because saya kata alphabet ada banyak kan. So it can be any letters that involved. There will be many letters that will be involved. So for example, this question example 12, it says about current. So current yang awak belajar dalam fizik, electric. So those yang nak further dalam electrical engineering must be very familiar with this one. Current. I. The symbol for current is I. Tak bolehlah suka hati. Kita tahu dalam law of physics, current dia punya simbol adalah I. Kita tak adalah nak pakai lambda ke delta ke apa. So selalunya current yang kita pakai I. Okay, the basic equation governing the amount of current in a simple RL circuit. So you don't really have to understand this one for mathematics, but you have to know what is the equation given to you. So it says the equation given by di over dt plus 50i equals to 5. So that's it. This is your differential equation. So you can extract the information from the given problem there, meaning that you have to identify first what is your variable involved in this application question. So kita perasan dekat sini, variables yang ada adalah I dengan T macam tu. So kalau biasanya bila kita jumpa differential equation, selalunya melibatkan Y dengan X. So awak akan cuba nak separatekan Y dengan Y, X dengan X. Tapi bila kita masuk application problem, it can involve many other variables such as this one, I for current and T for time. Alright, so the first thing that we need to do whenever we have a differential equation, what we have to do first? We have to try to separate the variable. Okay, when we try to separate the variable for this differential equation, we simply cannot separate them, or we can. Okay, so if we cannot separate them, or we can see that this is in the general form of our first order linear equation, we can straight away identify the techniques for integrating factor. So saya tulis balik sebab tadi tak apa orang kata, tak kemas. So di over dt plus 50i is equals to 5. So dalam kes ni, kita dah dapat satu general form of differential equation. So kalau awak perasan, this is dy over dx. Ingat tak? Kalau kita buat integrating factor, we have actually dy over dx plus pxy equals to QX. So this is what we have here, tapi dia tak familiar sebab dia tak pakai Y dengan X. Dia pakai I dengan T. But it's still the same thing, same differential equation. Okay, so as you can see here, we have our P, kalau dalam kes ni PX. So dalam kes kita, it should be PT. So PT is equals to 50 and QT is equals to 5. Kenapa in terms of T? Because this differential equation is di over dt. So kalau dy over dx, yes, px dengan qx macam tu. Okay, so now we have to find our integrating factor. So ingat integrating factor kita namakan dia sebagai V. So kalau sebelum ni Vx is equals to e to the power of integration of px dx. You will have no idea what I'm talking about today if you don't actually look back what we have learned in 2.2. Okay, so integrating factor kita, kalau sebelum ni kita pakai Vx, so untuk case equation ni kita akan pakai Vt is equals to e to the power of integration of pt dt. So we will actually have e to the power of 50t. So integrate, ni saya skip. Integrate 50 with respect to t, you will get 50t, so it should be 50t like this. So this is your integrating factor. So siapa yang dah dapat sampai sini dapat integrating factor, meaning that dah bagus lah tu, dia dah boleh cari integrating factor using this formula. Okay, this is the next step. Okay, so this is the third step actually in our integrating factor. Next, what we have to do is we have to multiply everything, our general form, with our integrating factor here, which is e to the power of 50t multiply with di over dt plus 50i, our integrating factor e to the power of 50t equals to 5e to the power of 50t. So this is the actually the important part of multiplying everything with our integrating factor here. Okay, our VT here. So yang belah kanan ni sebenarnya yang penting. Sebab sebelah kiri ni we can just write it as, remember what I said last time? We can write it yang belah kiri ni as D over dt. So kalau dalam kalau awak confused dengan dia punya variable yang berbeza sebab selalunya pakai X, tak apa, tulis kat tepi ni. Selalunya kita ada D over dx, D over dx dalam kurungan Vx dot Y. Okay, sama dengan kita punya Qx darab dengan Vx macam tu. Yang ni lah Vx darab Qx. So apa yang kita nak kena letak kat sini, kalau dah selalunya D over dx. So untuk case I dengan T, kita akan letak D over dt. Our Vx, so our integrating factor here is e to the power of 50t. Kita darabkan dengan apa ni? Darabkan dengan Y. So, siapa Y dalam kes kita sekarang? Y dalam kes kita sekarang adalah I. So, it's I. Macam tu. So, equals to 5e to the power of 50t. So, this is the part yang kita kena dapatkan so that we know how to solve it. So, lepas ni adalah untuk solvekan dia sahaja. But then, untuk dapatkan this part is very important lah. Kalau you salah dekat this part, maksudnya tak guna kita buat kat bawah tu, because it will be all wrong lah. Sebab kita even kita integrate pun kita tak dapat jawapan yang betul sebab kita punya equation kat sini salah. So make sure this one is correct. So how to know that this one is correct? We must have the correct integrating factor. So that's why, as I said just now, it's very important for you to get this integrating factor correctly. Alright, now kita buat macam ni untuk hilangkan D over dt ni. So how to actually cancel off this differentiation? We have to integrate both sides. So when we integrate both sides, we actually have e to the power of 50t multiply with I is equals to integration of 5, kita boleh letak luar, e to the power of 50t dt. Yes, you will be, untuk matematik, you will be even more confused kalau you tengok sahaja. So nak tahu, you boleh buat ke tak, bukannya just watch me write this one down, is actually to do it. Okay, try buat sendiri, barulah you boleh tahu you boleh buat ke tidak. So now we integrate e to the power of 50t, we will get e to the power of 50t over 50 plus c like that. Okay, so I is equals to, okay, kita tak nak I darab e to the power of 50t ni, tak nak macam tu. Kita just nak I sahaja. So what we gonna do is, okay, kita boleh bawa dia turun bawah. So we actually have 5e to the power of 50t over 50 e to the power of 50t plus c over e to the power of 50t. So kita tak boleh anggap ini sebagai the whole constant Why? Because it has a variable t here. Kalau dia hanyalah a constant, then you can give it another name like A ke. Tapi sebab tak boleh, we have to write it like this lah sebab ada variable t ni. Okay. So now we can simplify this further. So we can cancel off this one. 5 dengan 50 dia akan jadi 1/10. So we actually have 1/10 plus C to the power of E to the power of 50t like that. Okay. So this is your solution for I. This is the general solution. But then the question gives you the value of T and the value of I. So we can find our C here. So we can substitute T equals to 0 and I equals to 0. You will get 0, 1/10 plus C e to the power of 50 times 0 is 0. So e to the power of 0 is 1. So C is actually negative 1/10. So we can write back our answer here in the form of particular solution. We can write it as, so we said, so I, instead of 1/10 plus C over E to the power of 50t, it will become C tu adalah negative 1/10. So negative 1/10 over E to the power of 50t. In maths, it's so not proper if we write something like this. Ada banyak fraction dalam fraction. So negative 1/10 here also can be written as negative 1/10 like that. And you can also factorize lah negative 1/10 tu. So this is enough for your answer. Nak factorize 1/10 pun boleh. You will get 1/10. 1 minus e to the power of negative 50t. It's also correct. Whatever the context of the answer will be, so you choose from there. So the most important thing about this application question is to get your differential equation correctly. So it's actually given to you lah. Given to you. Okay. And then how you solve them, tapi kita tak pakai y dengan x. So that's why we have to be very clear with what we have in 2.2. Sebab kalau awak dah buat latihan 2.2, you will see that we have all these steps. Dapatkan the general equation and then finding the integrating factor, and we can write them in this term. Okay, once you know all these steps, kalau dia tukar variable pun, it won't be any problem to you. So this is just the same like what we learned in 2.1 and 2.2. It's just that the variables here are different. So kalau sebelum ni kita selalu pakai y dengan x, so untuk application ni dia ikut kepada variable yang soalan tu nak. Alright. So this is one example from example 12. So don't worry. I will give all the solution to you. Okay, so this is the solution. I kecilkan. Okay. Boleh tengok dulu. Alright, next one kita nak pergi kepada example yang seterusnya. So as I said just now, untuk your syllabus, even though there are various application that we can use for differential equation, but in your syllabus, the application that the real world problem that they are using is quite repeatedly. Contohnya macam selalunya mesti akan ada soalan current, selalunya mesti ada soalan population, selalunya mesti ada soalan temperature, soalan decay of radioactive. Dia ulang-ulang yang tu sahaja. So that you have to actually master this, some of this example of the real world problem lah. Okay, so kita tengok soalan yang seterusnya, contoh yang seterusnya. So semua orang okey lagi ke? Let me see what happened dekat dalam YouTube. Boleh? Okey, boleh dengarkan suara saya? Alright. So I'm just reading the comment. Oops. Alright. Okay, boleh. Thank you, Sofia Edina. Alright, so kita pergi kepada example seterusnya. Example 13. This is a very easy example. Kalau tadi kita pakai integrating factor, so kita tengok soalan ni, kita boleh pakai separable variable dengan mudahnya. Alright. A bacteria with population of 200 is used to start an experiment. It is found that the rate of the population growth of the bacteria dy dt is given by dy dt equals to 0.04y, where y is the population at the time t minutes. So, kita dapat je soalan application, you know that you will have the equation, the differential equation will be given to you. So, you have here dy over dt is equals to 0.04y. But your problem here must be your variable. So selalunya kita pakai y dengan x. So sekarang dia pakai y dengan t. And then there are only two techniques of solving the differential equation, is either using the separable variable or using the integrating factor. So in this case, as you can see, we can actually use the separable variable method. So kita akan separatekan y dengan yt dengan t. You will actually have, let's say I nak keluarkan y ni, tak nak dekat sini. So it will be here lah. 1 over y dy is equals to 0.04 ni I remainkan dia dekat situ. Okay, lebih senang nak orang kata apa, deal dengan constant ni kalau dia berada dekat atas, tak ada kuasa negatif, tak ada 1 ke apa. So remain dekat situ, y saya bawa pergi sebelah. Okay, dt dekat sini lah. So as you can see, we have separate the variable. So when we separate the variable, we can find the integration for both sides. So here we will get ln y, and here we will get 0.040 plus c, like that. Okay, so this is the problem where we want to find y only. We don't want ln y. We want y only. So what I said to you last time, we have to exponent both sides. So when we exponent both sides, okay, if Dalila is watching, so this is how we exponent both sides. So e ln y, so it's equals to y. And here, the common mistake that I said people always do adalah dia akan buat e to the power of 0.040 plus c. Macam tu je, dia buat turun salah. Okay, this is one thing that people always do. Okay, that's wrong. Okay, another thing that people always do adalah dia buat plus EC. Pun salah juga. Okay, so this common mistake, please don't do it. It's actually, we are using the index rule. So it should be dot EC, like that. Okay, since E is an Euler's number, a constant, E is an Euler's number, constant, C also a constant. So we actually have a new constant here. That's why we can write it as y equals to A constant kan, e to the power of 0.04 t. So that's what we have here. Okay, now we can find our constant here by substitute the information given to you. As for the example, it's given to you the value of t. So it asks you to find y. Dia tanya, what is y when t equals to 50? Okay. So kat atas ni dia ada bagi satu information. This is a very important information. A bacteria with population of 200 ni, maksudnya dia nak cakap Y adalah 200 masa mula-mula sekali eksperimen. To start an experiment. Okay, start an experiment ni, so listen to me carefully. When it says start the experiment, meaning that the value of T is 0. So the value of Y is 200 when the value of T is 0. So this is actually the information given to us. And it says find the population of the bacteria after 50 minutes, meaning that dia nak suruh kita cari what is the value of Y after 50 minutes when T equals to 50. So this is the question. Dia tanya Y sama dengan apa when T equals to 50. So this is what the question actually asks. Alright. So kita akan substitute nilai T equals to substitute T equals to 0, Y equals to 200. To our equation here, we actually have 200 equals to AE 0.04 times 0, which is 0. E to the power of 0 is 1. So A is equals to 200. So what that we have here is Y is equals to 200 E to the power of 0.04 T macam tu. Kalau ada yang saya tengah explain dalam lecture ni yang awak tak faham, boleh screenshot je. Bulatkan dan tanya je dekat saya terus ya. Alright, so A is equals to 200. So instead of writing it as AE 0.04T, so we write it as 200E 0.04T. Macam tu. And then the question asks you, what is the value of Y after 50 minutes? Meaning that when T equals to 50, what is your value of Y? So we just substitute 50 into our equation here. We have 200 is 0.04 times 50. So you just use your calculator. 0.04 times 50. You will get 2. So it actually wants you to find 200 E to the power of 2. It's equals to 1477.81. So this is the number of population for bacteria. So since this is the number of population, so we can also approximate the answer. If the answer given to you not in the decimal form, you can actually write it in the whole number as an integer lah. Maksudnya tak ada perpuluhan because it's a population. Okay, let me check betul tak 200 E kuasa 2. E. E. Sorry, E2. Okay, 1477.81. So we approximate it to 1478 because we are talking about the population of bacteria. So this is actually how we do it. And this is how we find the information given to us from the problem given. Okay. So this is example 13. Okay, there are two more example 14 and 15. So let me just give it to you in the Telegram channel of how we are doing it. So example 14 is about the Newton's law of cooling. So this is a very famous question. But just if you don't understand it, just let me know. So this is temperature, and example 15 is about radioactive decay. So the radioactive decay punya formula ni, it's very famous. I don't remember if you have learned the radioactive decay formula in the SPM. However, the formula, this is the formula for Newton's law of cooling. And this is the formula for radioactive decay. This is a very famous formula, and you should know how to actually deal with this equation. Okay, so I think two example for you today for the application is enough. Try to understand them, and I will give you the solution for example 10, example 11, example 14, and also example 15 for you to copy and for you to complete your notes. So these two application is enough for today, for this morning. So I hope that you get the idea of doing the application question for differential equation. So as you can see, we have done two types of application. This current is about using the integrating factor, and this population of bacteria is about using the separable variable. So those two examples are enough for you this morning for you to comprehend first. If you have any problem, just let me know. So your work for today is to complete your exercise for 2.1, 1.1 to 3 is very easy. I think everyone have done it. Question for 2.1, 1 to 3. And also please everyone continue with 2.2 question one only, because question one got five question A, B, C, D, E. So I want everyone to try to do integrating factor perfectly. Question one, two, three, four, five. I mean question one A, B, C, D, E. So ada 5 soalan dalam tu. Tolong buat dulu integrating factor tu. Tengok boleh buat ke tak integrating factor. Meaning that you faham ke tak how to do integrating factor. Then we will discuss some more about the application question. You don't have to worry about the application exercise. Just please complete exercise 2.2 question 1. Ada 5 soalan dekat situ. I just want to see everyone can do integrating factor well. So that's all for today. Don't worry, I will give you the complete notes so that you can complete your notes and all. So itu sahaja daripada saya untuk pagi ni. Saya harap dua contoh tu dah bagi a glimpse of idea on how to do application on how differential equation can be done actually in our real life. So satu tu radioactive decay. So satu lagi radioactive decay dengan Newton's law of cooling, nanti you boleh sambung. Okay. So hopefully you get the glimpse of idea on how to do the application again. Sebab saya tak nak bagi banyak-banyak contoh application, nanti awak pening. So dua contoh tu sudah cukup untuk memberi idea kepada awak lah on how we do application in the differential equation. So thank you everyone. Have a good day and I'll see you again. We have extra class also tomorrow, I think, for Thursday. So that's all. And thank you everyone. I'll see you in the tutorial. Don't forget to complete 2.2 question 1. Bye and Assalamualaikum. Actually, I have interview today, so everyone please pray for me. Okay, H5P4 and H5P3, I can't do our class today because I have an interview coming around. So I will give the work for you and I will upload the video for tutorial 2 for H5P4 and H5P3. Please complete your exercise on 2.2 question 1. Thank you everyone. Have a good day and Assalamualaikum.